In this lesson, we are going to cover Unit 8, Acquisition 1 on calculating rates of reaction. So first, let's start by talking about reaction rate. We know kinetics is all about how quickly a reaction occurs. When we are talking about the reaction rate, we are going to be looking at the change in concentration of either the reactants or products. We can do either. The change in concentration of reactants or products per unit of time. So think of this like a recipe. The reactants are like the ingredients, the products are what you're making. Let's say we're making cookies. Well, as our reaction or as our recipe goes on, we're using up all of the ingredients. We're using up all the reactants. So concentration of the reactants are going to decrease over time because they're getting used up. As we use up those ingredients, we could make more cookies. Concentration of the products will increase over time. So reaction rate is going to tell us how quickly those reactants get used up or how quickly those products get made in a certain unit of time. In this class especially, we are going to use the units molar per second. Usually measured in the units molar per second. So molar represents the change in concentration per second. These units can change. If you have a slow reaction, we might measure it in minutes or even hours, but usually you're going to see molar per second. Let's talk about that recipe example I just said. This will be important to know. As a reaction proceeds, two things happen. Reactants get used up so their concentration decreases. Just like if you're making a recipe, if we're making cookies, you're going to use up your flour, your eggs, your sugar. Their concentration is going to go down. Products are formed so their concentration increases. As we use up all of our ingredients, we can make more cookies. As you use up your reactants, you can make more products. Let's look at a quick graph. Alright, so let's say we recorded concentration over time. One of my curves looked like this. The other one looks like this. We'll talk about why they level out in a later lecture. You should be able to look at this graph and tell me which line represents the reactants and which represents the products. Well, we said reactants, their concentration decreases over time. So this blue curve would represent the reactants. The pink curve would be the products because the products' concentration increases over time. I like to call these our fish graphs because it kind of looks like those fishes that you probably used to make. it looks like a fish. So those will be forever called our fish graphs. All right, so let's talk about how do we calculate rate. Remember, we can express it either way, the change in concentration of reactants or the change in concentration of the products. So rate can be expressed as the rate of disappearance and again, which one is disappearing? The reactants. Or it can be expressed as the rate of appearance of the products. Regardless of which calculation we are performing, rate is always positive. This will always be a positive value. Rate is expressed as a positive quantity. All right, so let's write down our equation and then we'll look at a few examples. If we want to calculate the average rate of reaction, it's exactly what we said, the change in concentration over time. So we're going to take the change in concentration and we are going to divide by the change in time. First example. Let's say this had a simple reaction. A produces B. And we were to record the concentration of A, the concentration of B, at certain moments in time. These brackets represent concentration. So whenever you see something in brackets, that just represents concentration. Another important thing to note, sometimes you're not going to be given all of the information. Let's say at a time of 0, I had 1 molar of A. Well, the concentration of B would be 0. Sometimes you won't be given that value, but you should know that it's always going to be 0. Before this reaction occurs, I have 100% A and I have no B. Again, think about it like we're making cookies. You have all of your ingredients, but before you start making them, do you have any cookies yet? No, so that concentration is going to be 0. A is my reactant. Concentration of the reactant is going to decrease over time. So notice that the concentration of A is decreasing. The concentration of B is increasing. Let's say we took a measurement every 20 seconds. Another important thing to notice is this is a 1-to-1 mole ratio, so notice that our quantities always equal 1. Number 1. Calculate the rate of appearance of B over the first 20 seconds. So all we have to do is plug this in to my formula. So we're going to take the change in concentration and we're going to divide by the change in time. And I want to look over the first 20 seconds. Remember, rate is always positive. So 0.46 divided by 20 gives me 0.023 molar per second. B is appearing at a rate of 0.023 molar per second in the first 20 seconds. Let's try one more problem with this data table. All right, so question 2. Calculate the rate at which A disappears over the time interval from 20 to 40 seconds. Calculate the rate at which A disappears over the time interval from 20 seconds to 40 seconds. Alright, so now I'm looking at A, and I want to look at my data from 20 seconds to 40 seconds. We're going to use that same equation. Rate is equal to the change in concentration over the change in time. Remember we said rate is always going to be represented as a positive quantity. So I'm going to take the change in concentration I'm going to divide it by the change in time, 40 seconds minus 20 seconds. And then you just have to be mindful of your sign. So when I put this in my calculator, I get negative 0.012. But remember, rate is always a positive quantity. And then we don't want to forget units. Molar per second. Pay attention to the data table. Again, it is usually molar per second, but not always. All right, let's do one more problem, and then I want to talk about a trend that you're going to see. All right, so for this data table, I'm just going to give you some information about the concentration of A. And the time intervals that we have. So in this case, we see that A is disappearing because it's decreasing over time. and we're recording how long it takes to decrease by 0.0005 molar. So what I want you to do is to calculate the rate for each time interval. So we're going to do 3 calculations. From 0 to 10.5 would be the first interval. 10.5 to 22.3 would be the second interval. And then we have our third interval. So let's go through and calculate these. I think you guys can pause the video, try these on your own. This should be a pretty simple calculation. All right, for the first rate, hopefully you got 4.8 times 10 to the negative 5th. I did the change in the concentration divided by the change in time. Rate is always a positive value. For my second interval, same thing. Let's take the change in concentration and divide by change in time. And then lastly, our third interval. All right, so we have our 3 answers. So I want you to look at what is happening from interval 1 to interval 2 to interval 3 and notice what happens to rate as the reaction proceeds. Well, the rate is going to decrease. The rate decreases as the reaction proceeds. Why do you think that happens? Take a second and think, why would rate decrease as the reaction goes on? And the reason is because the concentration of the reactants decreases. All right, so as our reaction goes on, reactants are getting used up. As those reactants get used up, you have less reactants. The less reactants you have, the less products you can make. That reaction is going to slow down. So as the reaction proceeds, notice that the rate is going to decrease because we have less reactants. The less reactants we have, the less products we can make, so we're going to make less products over the same unit of time.